Welcome back, everybody. We're going to do a little bit more with the addition and subtraction identities. So make sure you have your formula sheet handy. Today we're going to be going backwards a little bit for part of the time, and then we're going to apply this back to some triangles in the coordinate plane at the end. So first, if you look at this, these two examples, we want to identify if these are sine, cosine, or tangent addition properties. And then we just need to then decide, are they addition or subtraction? So if we look here, we have sine, cosine, cosine, sine. So in our little song, those came first. So those are our sine identities. And sine, if it's addition in the middle, then it's going to be the addition identity for sine. So this is going to be sine of 80 degrees plus 10 degrees, which is sine of 90 degrees. And this one, sine of 90 degrees, if you think of your unit circle, is equal to 1. So it will simplify to that. Next, we are looking at cosine, cosine, sine, sine. And that's the one in the song where we said cosine, cosine, sine, sine, sine. So that means this addition in the middle means this is a cosine identity of subtraction. So cosine of 79 degrees minus 37 degrees. Okay, then we carry that out. 79 minus 37 is 42. And 42 degrees isn't on our unit circle, so we can just leave it as cosine of 42 degrees. We can do the same thing with radians. Here we have cosine, cosine, sine, sine. So this is a cosine identity. Cosine, cosine, sine, sine, sine. So that sine in the middle changes. So this is going to be cosine of 7 pi over 8 plus 3 pi over 8. So that is cosine of 10 pi over 8. We can simplify that 10 pi over 8, reduce it down to 5 pi over 4. And 5 pi over 4 is on our unit circle, and the cosine of 5 pi over 4 is negative root 2 over 2. All right, this next example, we have sine, cosine, cosine, sine. So that's a sine identity. So the subtraction in the middle will stay subtraction. So this is sine of 9 pi over 10 minus 3 pi over 10. And that's equal to sine of 6 pi over 10, which if we reduce that fraction, we get sine of 3 pi over 5. It's supposed to be a 5, not a 6. I'll just erase that. There we go. Sine of 3 pi over 5. 3 pi over 5 is not on our unit circle, so this is our exact final answer. All right, another way we can use our addition and subtraction identities is to simplify angles and simplify expressions. So since this is sine of pi over 2 minus x, we're going to use our sine identity for subtraction and rewrite this out. So we are going to do sine cosine minus cosine sine. And then substitute in where we can. Sine of pi over 2 is 1 times cosine of x. Cosine of pi over 2 is 0 times sine of x. 0 times anything is just 0. So we get 1 times cosine x, which is just cosine x, minus 0, which is just cosine of x. So sine of pi over 2 minus x is equivalent to cosine of x. Then if we do secant, Remember, that's a reciprocal, so this is equal to 1 over cosine of pi over 2 plus x. So what I'm going to do is just find that cosine using the cosine addition identity. So that's going to be cosine, cosine, sine, sine, sine. Then simplify. Cosine of pi over 2 is 0 times cosine of x, minus sine of pi over 2 is 1 times sine of x. 0 times cosine of x is 0, minus 1 times sine of x is sine of x. So cosine of pi over 2 plus x is negative sine of x. But remember, we need the reciprocal. This is 1 over cosine of that. So the reciprocal of negative sine x is negative 1 over sine x. So this is actually equal to negative cosecant of x. All right, and then lastly, now we have a problem where they're giving us what cosine is equal to, and they're telling us it's in a specific quadrant. So what we're going to do here is draw our 4 quadrants. 0, pi over 2, pi, and 3 pi over 2. This angle x is going to be in quadrant 4 between 3 pi over 2 and 2 pi. And then cosine of that angle is 2/5. Cosine is adjacent over hypotenuse, so 2 here and then 5 at the hypotenuse. We just have to find our vertical side, so 2 squared plus our vertical side length is equal to 5 squared. So y squared equals 25 minus 4, which is 21. So y equals the square root of 21. And this is a negative value, so negative square root of 21. All right, now if you look here, we're trying to find cosine of pi over 6 minus x. So let's apply our identity. Cosine, cosine, sine, sine, sine. Then from here, fill in, substitute in what we know. Cosine of pi over 6 is 1/2. Nope, root 3 over 2. Pardon me. Cosine of x, lo and behold, is 2 over 5. That's what they gave us at the very beginning, up here. And then sine of pi over 6 is going to be 1/2. And then sine of x, we're going to use the triangle to get. So remember, sine is opposite over hypotenuse. So sine of x equals negative root 21 over 5. So we get 2 root 3 over 10 plus negative root 21 over 10. And then combine those because they have the same denominator. So 2 root 3 plus a negative is like minus root 21 all over 10, like so. Now, important to remember, what people tend to want to do is when they see sine of x plus y, they're tempted to distribute and think of this as sine of x plus sine of y. Remember, this is a function. The x plus y is inside the function, not being multiplied. So this is what you're going to want to do. Sine of x plus y or cosine of x plus y or tangent, whether it's addition or subtraction, always use the identity. It's a special type of distribution, if you will. Okay, so make sure always use your identities in these cases. Just can't stress that point enough. So you do have a daily task on Schoology today. Go check that out. The 9.2 worksheet, You can look at a few more examples that were like the ones we did in class today, especially if there's any that you aren't feeling comfortable with, and ask me for help today at all if you need it, or check into the Google Hangout. See you later.